Good morning, everyone. Our topic name is Neural Network Based Term Deposit Subscription Prediction. Submitted by myself, Deepakyan, Raju GH, Sandeep Shivanand Balla, Yuvraj V. Bajantri. This project is submitted to Sheikh Dawood Said Sir, Assistant Professor of GM University, Davangere. We are going to discuss introduction, problem statement, data set description, data processing, neural network model, model training, evaluation matrix, confusion matrix, results and insights, conclusion, references. Introduction. In the modern banking sector, understanding customer behavior and prediction future action is crucial for decision effective marketing strategies and improving customer engagement. Financial institutions often promote term deposits to customers. Predicting customer responses improve marketing efficiencies. Machine learning helps automate the decision making. Neural networks can learn complex customer behavior patterns. Our project builds a neural model to make decision prediction. Focus is improving accuracy, recall, and precision. Problem statement. Need for an intelligent system to predict likely subscribers. Our main goal is to build a neural network that accurately predicts customer interest. Further continued by my teammate Sandeep Shivanand Balla.
Myself, Sandeep Balla, I am going to explain objectives. Build an accurate predictive model using neural network. Creating a model that makes price prediction using AI. Automate customers classification as subscribe or not. Automatically decide if a customer will subscribe or not. Minimize marketing effort while increasing success rate. Reducing market costs but get better result. Enhance customer targeting with the data insights. Use data to better identify potential customers. Improving financial outcomes for a banks. Helps banks make a more profit. Test, validate, and model with the real world data. Check the models accurate using actual data. Dataset description uses the bank marketing dataset from USA repository. Data is from a popular public dataset source, including 16 inputs, attributes, and one target column. Future, age, job, marital status, education, etc. Label column yes, no for the terms deposit subscription. It's a sample data. For example, age, job, marital status, education, balance, subscribe. For first one, we have age of 35 years and job is admin and marital status is married, education is secondary and balance is 1200. Subscribed yes. And further, we have same examples like age of 42, 29, 51, 37 and job is technique, service, prepared, blue collar and marital status is single, married, divorced, single. And so education is territory primary, secondary unknown. Balance 2400, 600, 3850. Subscribers like no S, no S. Next slide. Data pre-processing. Load the data using pandas and clean it thoroughly. Import data and remove unwanted parts. Handle missing values and remove noise. Fill or drop blank and fix messy data. Apply one hot encoding to categorize field. Convert the categories into numbers. Normalize numerical values using minimax scalars. Scale number to a uniform range. Split dataset into training and testing sets. Dividing data for model learning and evaluation. Ensures dataset is balanced and properly formed. Make sure classes are and next will be continued my teammate Raju GH.
Myself Raju GS. Today we are discussing about neural network architecture. On this slide, we explain the neural network architecture used for term deposit subscription prediction. The model is built using TensorFlow and Keras libraries. The input layer corresponds to the number of futures in the datasets. two hidden layers use the RLU activations functions to introduce the non-linearity. The output layer uses a sigmoid activations function. Since it's a binary classification problem, we complain that model using binary cross entropy laws and optimized it using the Adam optimizer, which provides the fast and efficient learning. We move on to the next slide. In model training, this slide shows the training phase of our model. We trained the model using 100 efforts to allow sufficient learning. A batch size of 32 was used to ensure the efficient training. During the training, we tracked both accuracy and loss to monitor model performance. We do not use early stopping as we wanted to observe the complete learning curve. The model is gradually learns pattern that distinguish subscribers from non-subscribers. Finally, it outcomes predictions the probability of between 0 and 1. We move on to the next slide. In this slide, in this model evolution phase, we tested the model on unseen test data to measure the performance. We used two confusion matrix to visually analyzing the predictions, and key matrix used for accuracy, precision, recall, and F1 score, which offer a well-rounded evolution. The model shows the strong ability to identify the potential subscribers. However, some false positives and negatives still exist. This evolution step is crucial as it helps us identify how the model can be further improved. Next, we will see the code of this project. Next we demonstrate the Python code. We are using that TensorFlow info and warning. We have importing the OS and importing pandas and scale model selection, and import train test split, and after importing the Matplotlib libraries, we have load the dataset like we have seen that data set like this type of data set like age, job, martial education, and difficult. We have used to this code to run for data set, and for encoding the categorical columns, we have taken the difficult column and transfer into column, and after that we have to split into features and target like x-axis and x and y, and we have to train the test split, x train and x test, y train and y test, future scaling, scalering standard scalar, and x train scalar fit transfer into x test is equal to scalar transfer x test, and next we move on to the split features and targets. After neural network model, we have input the shape and train shape, and compile the model. We have taken the binary cross entropy and matrices accuracy, and train the model like history is equal to model fit, like epochs 50, batch size is equal to 32, validation split is equal to 0.2. After that we have taken the prediction like int 32, and evolutions after that evolution like confusion matrix, we have taken the true and true negative and true positive, and true negative and false negative. According to the confusion matrix, we have taken the classification report like 0 division is equal to 0. Next, visualizing the confusion matrix. Let take the one figure like matrix like 6, 4, and title like confusion matrix predicted and actual. Next, we have taken that it is the some extra we have taken that to finding the accuracy, effect accuracy, and we let's run this code. After that output, it likes the FARC 1 comma 50. It finding the accuracy, and we have this is the confusion matrix of diagram. We have taken the actual yes no yes predicted, and this is the confusion matrix. We have taken that output. uh, this is the figure that accuracy and loss and accuracy and effort. This blue line is the train accuracy, and this is the yellow color is the validation accuracy. We have output that, and the, after the output, that given the confusion matrix like 0 comma 0 and 1 comma 0, and the overall classification report like precision, recall, F1 score and support like 0 1. We have taken that F1 score and accuracy and weighted average. Next, we move on to the confusion matrix. This slide explains the confusion matrix, the key tool of evaluating the classification models. It shows the predicted outcomes versus actual labels. A true positive means the model correctly identifies a subscriber. A true negative means it currently predicted a non-subscriber. A false positive and false negative indicates the misclassifications, such as the predicting a S when it should be no, or vice versa. Understanding this matrix helps in the refining our model to reduce errors and improve reliability. The next slide will continue by my teammate Yuraj.
Results and accuracy. Final accuracy achieved 88%, sample 88%. Balanced permission and recall matrix. Completion model generalizes while on unseen data. Shows value is using deep learning marketing. Compared with the baselines models, results uncovers real world accuracy. Next slide. Mm, Advantages and limitations. uh, Requires large leaded data sets to perform well. Uh, Transform time can be high for deep networks. Model can overfit if not properly transferred. Immediacy of natural network is slow. Successfully implemented a natural network model. High accuracy and ability to other data sets. Works with complex non-linear data. Thank you all.